Alright, how you guys feeling today?
Alive.
That's a good place to start. Hope that continues. So let's see. We had a test last week, and overall, everyone did very well. Everybody passed. No issues with any student in particular, actually.
We did do worse than the first one, right? It was harder.
I feel like it's different for every person. Some people, let me check the actual average. The average itself is probably a little lower, but this is the material that you guys would just be less familiar with, which is fine.
And more, right? Was it? Well,
This was all of electricity and magnetism that we talked about, which, just assuming you guys have had more chemistry than physics, is the stuff that you've probably seen the least of. So that's fair. But again, everyone did great. So seriously though, good job, everyone. I emailed out your corrected score. So if WebAssign is currently showing you a score, I don't know if I actually set it to reveal. It might not actually, because it's still going to show you the wrong answers if you got it right. The number I gave you in the email that was a reply to your work that you sent is the number of points that you got, which is graded out of 100. So the number is the score going into the grade book, and the comments below are just a brief synopsis of where points got taken off. If I didn't mention a question, you got it completely correct. Does anyone have any questions about anything from the test related to electricity and magnetism at all? Okay. So, once again, great job, everybody. Now, you're going to be moving towards the end of the semester. You're almost there. Kind of hard to believe it. Oh, wow. I would miss you guys. But we have at least, including exam week, it's about 3 weeks left. So this particular week will operate pretty normally. We're going to be having a lecture. We're going to be learning about, or continuing to learn about waves and such, and working on exam prep as well. We will also have a lab this week. Lab itself will be a little different in that I think I mentioned the little Scantron end of course, end of physics test that we're going to do at some point. Very literally the same as the one you took at the start of Physics 1500. That was just an inventory, seeing where everyone was when they came in. I think, so we don't have to give up any class time for it, I'm thinking that the best time to do it would be as a preface to lab, because everyone will come in, do it, and then we can get on with our business. That said, I have an appointment this particular afternoon, getting my second and final COVID vaccine shot. So, kind of a weird schedule. We will have normal lab all this week. So do come to lab all this week, whenever your assigned time is, or whatever day you attend. But, because I need to guarantee that I can have everything wrapped up in time for me to go get my shot, only Wednesday and Thursday lab are going to be taking and it's capped at 30 minutes. It won't take long. It's not hard. It's just the same inventory questions you took before. Only Wednesday and Thursday will take that brief Scantron assignment. This week, I would like to very humbly ask that even though there's no lab next week, that whoever has Monday lab would come on Monday next week. Whoever has Tuesday lab would come to the lab room next Tuesday to do that brief 30-minute assignment then. that's all you would have to do that day,
Mhm.
because there is no other assignment that week, just to make sure that it's fair that there's no assignments in that last week. But it's a little wonky, but I feel like this is the best way to make sure it gets done and to make sure that I can still get my shot.
Is live this week gonna take like a little longer?
I just can't guarantee how long it will take, because this is the first time I've done this particular lab at this school. It's not that I think it's going to take very long. It's just I've noticed whenever I plan anything, it ends up taking longer than I expect. So I have to prepare for the contingency. This week, though, in lab, we are finally building the electric motors. And so part of the grade will just be, can you get it working? And if that takes a little bit of time, I want to plan in case that takes a specific group a certain amount of time, because A, you've never done it before, and B, because the axle can be kind of fiddly. So, this week, lecture, lab, there will be one last homework and quiz assignment, but those will be due, well,
That same Tuesday, like the 1st, or?
Tuesday is actually the 4th.
Oh.
The 1st is
Oh,
this
you're right.
Saturday.
Oh.
I mean, yes, the vertical part of the 4 is the easiest part to see up here with the resolution.
It's because there's 33 days in April. I'm just kidding.
That'd be a weird, the song for remembering days of how many days are in a month, it'd be a little weird to them. I lost my train of thought several times, so there, sorry about that. So,
Oh, the homework due.
yes. I might just make it due Friday, because I really don't. I think it's a school rule, there shouldn't be any assignments next week.
I have a test on Monday.
Oof.
Yeah, they said it was kind of illegal, but they didn't care, so it's okay, I guess.
And those rules exist so that students aren't pulling their hair out in the last minute. So, when in doubt, I default to trying to make things easier for you, at least you guys, and preferably me as well. None of us are getting enough sleep. I might just make it due Friday just to have it over with. It'll be a short assignment in that case.
So on, we have class Thursday, Friday too, right? So we can discuss.
Yes, this class will meet Thursday, Friday.
Mm-hmm.
And then after that, the only day we'll actually meet is next week is next Thursday. Sorry,
Tuesday.
I cannot say any words correctly today. I'm sorry. Next week we will only meet Tuesday because Thursday is reading day. So that'll just be it.
Will that be exam review Tuesday?
Yes. Try to make Friday that as well. This week, what I'm going to be preparing for you guys in terms of the exam is the chapter list of all the things we've talked about that will be present. Make sure that the formula sheets available for you are useful and updated and available, and more sample questions if you would like to work them. Those will all be on the Brightspace page and available for you soon. You'll spend some class time looking over and talking about the list and looking at all the formulas. Exam, same format as everything we've been doing, just more of the same. It'll be on WebAssign, and because it's online, it doesn't really matter when you take it, so it will open at the start of exam season, and you just have to take it within 6 hours by the end of exam season. And I'm not worried about any of you guys in the slightest, frankly. You guys have all been doing very well the whole year, whole semester. So I will be getting that list together. We can talk about it. Once it is officially written, I will make sure it is available for you guys to peruse and start looking at the practice stuff on Thursday at the latest. I should write that down. And for right now, make sure you come to the lab. And I'm just rambling again, going over. I'm still very sleepy. I apologize. How are you guys?
I sleep at 2, writing a paper.
That's not healthy.
Hey, I'm alive, so it must work somehow.
Human sleep cycle is a delicate thing and an important thing. Okay, I've already rambled through a lot of information today. Do you guys have any questions about anything at all? Okay.
Wait, just really quickly. Well, this was like on the example. So that last example we did with like finding the distance.
Mm-hmm.
And then we talked about how it's like for an echo it's the same, but it's doubled.
Yes.
So like we would solve for D and then we would divide by 2.
Well, let's actually do one together. I'm writing one up real quick.
An echo one? Is that right?
Yes.
But I thought like what you, I don't know, like
I think what you said is right. Sorry.
when you talk and like in an echo place or whatever, right? Isn't like the velocity different? Like on the way there versus the way back?
The velocity is not different. The waves, all waves of a specific type in a specific medium will travel at the same speed.
So then why does it sound different then? Shouldn't it sound the same then?
That does depend on a few factors, actually. An echo might sound different because, one, the thing that it hit has specific properties that change the wave. Because when an echo forms, it's not actually the exact same sound wave coming back to you. What happens most of the time is, and this is true with light as well, like I guess the light equivalent of an echo would just be a reflection. But when you send out an echo, that echo is going to strike some physical object, and that object, I just picked up 2 with the same color marker. So, you know what? Doesn't really help if the waves and the object are the same color. So when the wave hits the object absorbs the wave. Usually blanket statement. When sound hits something, the sound is absorbed by whatever it hit. Because waves are traveling energy, energy can go into various objects, so when sound hits something, it absorbs energy, and on some level, it's going to start shaking. This is one reason why when you crank up the bass, everyone's teeth within a square block start rattling.
Is that why glasses break? You know, like that opera thing?
Yes.
It is this?
Mm-hmm.
So it has like a what? It's like frequency is so, or what is it that?
With the wine glass specifically, every object has a resonant frequency, which is to say, there's a specific frequency that every single object in the universe likes to resonate at. When you hit something and it makes a sound, the sound it makes is the sound that it's designed to make. It's the sound that object wants to make when it vibrates. And when you blast that object with that same frequency, since it likes oscillating at that frequency, it just keeps vibrating more and more and more, and sometimes it just vibrates apart. In the case of the wine glass, the amplitude of its vibration increases such that it just can't hold together anymore. I actually have a visual I can show you for that momentarily. First, the echo.
Are you gonna sing for us? I'm just kidding.
I mean, I can. The songs I feel I can do well might not be everyone's cup of tea. So, sound wave hits, like if you're screaming into a cave because you want to hear your own echo, sound wave will hit the back of the cave wall and it will be absorbed. And then what you will eventually hear is new sound being produced by that wall. The wall makes the echo. It is technically a new wave being produced by the cave wall shaking because it absorbed the first one. And different materials have different propensities to release sound and also the light that they have absorbed, which is why I actually do a little bit of voice acting. And in order to cut down on echoes in the recordings, you have to line your recording booth with material that doesn't release those sound waves back out. To cut down on the echo, you just line the sound booth with sound absorbing, usually fabric and foam. Those things just don't tend to release the sound waves they've absorbed. Kind of like how if you wanted to cut down on ambient light in a room, maybe you're shooting a movie, you'd probably put a bunch of light absorbing materials all over the walls. So speaking of echo, this might not look like it, but it is an echo question. I think I mentioned the 30-minute input lag when you try to send a signal to the Mars rover. Have I not mentioned that? So, when anyone tries to remote control the Mars rover, they have to push a button saying drive forwards, and then nothing happens on their screen for 30 minutes. Because it takes 30 minutes for the radio wave signal to be sent all the way to Mars, processed by the rover, then it actually acts on the command, and it takes the rest of that 30 minutes for the camera signal for whatever changed to get back to Earth. So it's 15 minutes to Mars and then 15 minutes back.
But that's what I don't get. Like, why would it be the same? Like, shouldn't it have lost some energy?
Well,
like it should be like 5 and then 50, and then like 25 or something. You know?
Well, the waves travel at the same speed regardless of what made it or why. All radio waves are a form of electromagnetic radiation like light, and they will always travel at this speed. The wave's speed is set at this hard limit. When we send radio waves to the rover, this is how fast they go. Doesn't matter what we say over those radio waves, doesn't matter how loudly we broadcast it, that's how fast they go. Similarly, whatever waves we send to the rover will read them, do whatever it's supposed to do, and then send a different broadcast back. And so it's designed with a powerful enough sensor to send waves back to Earth at that speed, strong enough that we get the signal. Yes?
Does the medium change between Earth and space?
The medium?
Yeah.
Technically, yes. If the signal is made on Earth's surface, the waves have to go through air, then through the void of space, then through what little atmosphere Mars has, and then do the same thing in reverse. So technically, yes, there would be medium changes. I'm assuming all of our systems are designed to work around that, and that medium change would, most affect the frequency of the wave more so than its functional speed. Light and other forms of magnetic radiation are kind of strange in that, yes, when they enter a new medium, the speed should technically change, but we kind of shaped our math around the idea that their speed stays constant and it's their frequencies and wavelengths that change when they enter new mediums.
So, what medium increases like wavelength then? Like in this example.
The void of space is the least dense medium that we reasonably have access to. So going from void into air is more dense. That tends to make it functionally slower. That would make wavelength bigger and frequency smaller. They'd still multiply together to get the same number, but it's functional. No, it's functionally the same speed, even though dilating the wavelength makes it seem slower.
And then the opposite for air to void.
Yes, air to void, the frequency should rise. And the wavelength should shrink.
So that's what's happening with the echo, or no? It was at the same speed, so that's why I had the same time, but it wasn't necessarily the same frequency and wavelengths throughout the whole there and back.
Correct. It would still need to be similar enough for it to be produced and then read correctly. I think to make sure there's nothing lost in translation, I think we actually send most of these signals from a satellite in orbit instead of from dishes on Earth's surface, just in case. That would be it would save a few seconds on sending the signal. B, it makes absolute certain that you don't lose any data because you're going through the atmosphere. That said, most of our machines are designed to account for that because your phone gets data from satellites all the time, and it's just designed around the calibrations needed for that. I wouldn't say that it affects anything too much to where it would actually cause a problem. So, we know the speed of light. It takes the radio waves 30 minutes to get there and back, which means it really only takes them 15 minutes to get from Earth to Mars in the first place. What is the distance between Earth and Mars, roughly, then? And let's finish getting my number. On the any questions you have, I'm going to see if there are still tuning forks in this closet.
Wait, is this sound? Right? Is it sound?
No, this is light. Radio waves
Wait,
are a different flavor of light.
Right. Times in seconds.
Yes. pitchforks are old and busted, which affects their resonance, sadly. Okay, how far are Earth and Mars?
I got 2.7 times 10 to the 11th.
Mm-hmm. Yep, and that's in meters, which is a lot. So, you either need to cut the time in half or solve for distance with the full time and cut the distance in half. And normal sound-based echoes work the same way. If you scream into a cave and it takes you 3 seconds to hear your echo, you either use the 3, find your distance, and cut it in half, or you cut the time in half in the first place because it only took 1.5 seconds for the sound to reach the back of the cave. And dolphins and bats do this whole thing in their head. They use echolocation to figure out how far away from them something is. Fun fact though, I don't actually have notes prepped for this, unfortunately. I just think it's really cool. There's a second mechanism, in addition to just the time of the echo, that bats and dolphins can use to figure out if the thing they're sensing is moving towards them or away from them. You guys ever heard of the Doppler effect?
Oh, yeah. Oh, we did that. Didn't we do that in like physics 1? Wait, say it again?
Doppler effect.
I think we did.
I don't know if I've mentioned it. I don't think I've mentioned it.
No, like last semester.
Hey, I don't know why you would have. You could have. I mean, it's a thing he would talk about if it came up.
I'm like pretty sure we even had because we did bats in caves. I totally remember this.
Okay.
Oh my god, yes. I found
Yeah.
it. With the V source, V sound. Yeah.
Okay, yeah. We're talking about the Doppler effect.
Oh my god. I remember now. Okay.
So, one reason why the echo might sound different sometimes is if either the source or the thing it hit is moving. You guys have probably heard like a passing car or train sound, like the difference, there's a difference in how it sounds as it's approaching you versus how it's moving away from you. And it goes like, terrible impression, but the concept is there. If something is moving towards you, it's making a sound wave and then approaching that wave that it just made, which kind of shortens the wavelength, bunches it together. Meanwhile,
It moves it? It like squishes the wavelength?
kind of. Like, if I threw you a rope and then I walked towards you as you were catching it, the rope wouldn't be taut. Like, it might be just the perfect length of rope for it to be taut while standing between us, but if I'm walking towards you as you're catching it, it's not going to be taut when you catch it. That will effectively change the wavelength of the wave, even though the speaker on the ambulance was designed to emit a very specific wavelength of sound. Similarly, if I threw you the rope while I was walking backwards, you wouldn't catch it at all. So if you're moving away from the target, that will increase the wavelength and also change the sound. So again, bats and dolphins can listen for they know what frequency they emit, and they can tell, okay, it's 3 seconds away from me, and I can tell because the frequency went up that it's getting nearer, or because the frequency went down that it's getting further away. And this is how we track things in space. Because you don't really have depth perception when you're just looking at a faint pinprick of light several billion light years away. But if its frequency is increased, if it's red shifting, that means it's getting towards us. And if it's blue shifting and the frequency is decreasing, it's getting further away. So light and sound both do this. At this point, I think we're just talking about cool waves things that I like and that you've experienced on Earth before. You mentioned the wine glass, which I can show. And there's a good segue.
Wait, so you said that the wine glass is getting hit with the same frequency that it likes to. What? What was that concept?
Resonant frequency.
Okay.
Every object has a frequency that it really, really likes to vibrate at. That is best seen with a tuning fork. Each of these forks is designed to resonate at a specific frequency. They all have a different number and a different note written on them. This wooden box is designed to make the fork louder so everyone can hear it. And sadly, this is the only fork that fits in it. So this fork was designed to make a very specific note. However, with time and being beaten up by a stick and rusting and being touched by oily fingers, the object has changed somewhat, so it's not making the same pure tone it was built to make. This, I hope there's no instrument that makes that noise. But it still has a frequency that it makes when it naturally vibrates. Every object does, which is why every object inherently makes a different sound when you hit it. And the funny thing is, when one object is shaking at its resonant frequency, it's giving off waves of that type. If those waves hit a second object that has the same resonant frequency, they'll make it start shaking too, because it really likes shaking at that resonance. These forks have the same resonant frequency. They're both C notes. So I'm going to make one of them shake by hitting it with the mallet. I'm going to hold it next to the second one, and then I'm going to stop the first one, and we'll see if we can hear the second one, just from the passive resonance transfer. Well, nuts. Even if it was very loud, it wouldn't be transferring very well across this room. Because all these forks are old, and because they've been touched a bunch, their frequencies are all changed somewhat. So they might have been the same frequency coming out of the box, but they aren't anymore. What I can show you, though, is what happens when you shake an object at its resonant frequency.
So resonate means vibrate?
Resonate means it's vibrating at a very specific frequency. Come on, show the close-up. When you blast something with sound, the object absorbing the sound does vibrate. Most of the time, not very much. Your eardrum vibrates because it's absorbing sound waves, but it doesn't vibrate out of your head because you have to hit something with its resonant frequency for it to start shaking itself apart.
It can't be like higher?
No, it has to match perfectly.
Oh.
So I need to add these to my slide notes, and I apologize. You do have to match the frequency perfectly to force the object to begin resonating. Yes.
Is that what happens when we bust your eardrums?
It can. That said, I would hope that the resonant frequency of the human eardrum is not a sound we would actually be exposed to on a regular basis. However, every object has a resonant frequency, so yes, if you were to play that into someone's ear, their eardrum would just keep shaking until it eventually tore itself open, which does happen. Thankfully, the eardrum is really just skin, and of all the parts of your body, your skin is the one that regrows the most and the fastest. So there are some injuries that permanently destroy your eardrum, but it's surprisingly resilient, thankfully. It can regrow from a lot of abuse. However, every part of your body has a resonant frequency. That includes your bones. The wrong frequency of sound waves can literally make your bones rattle.
And shatter or just rattle?
I mean, they'd shatter if they were exposed to it for too long, but you'd probably be dead by then. If your skull was literally shaking, you'd concuss yourself before the skull actually broke.
Okay.
I assume. I'm not a biologist. So that said, I sincerely hope there have not been many people exposed to skull shattering frequencies. However, I do know of probably the worst and most famous case of an object, the one object you don't want to resonate, wound up resonating, and that was a bridge. Has anyone heard of Galloping Gertie? Full screen, please. I'm going to dim the front lights. Keep in mind, that thing's made of metal and concrete, and it's flexing like rubber. This is what happens when construction workers forget about resonance. This is the Tacoma Narrows Bridge, built some point within the last century, as evidenced by the video quality. It was built in a very specific place, and after construction was mostly finished, construction was finished. There were cars on the road, it was being used. But one day, not long after it was finished being built, a terrible wind swept through the area. And the wind was blowing at the bridge's resonant frequency.
Wait, so it can be. It doesn't. Frequency can be in light, sound. Like, what is wind?
The wind's gusts, or possibly oscillations in the force of the wind, matched what the bridge's resonance was.
Okay.
Which, this is like a 1 in a million, 1 in 6 quintillion situation. This shouldn't happen. But it did. The bridge was being shaken at its resonant frequency by a combination of the wind and its own construction. And any object exposed to its own resonant frequency will start shaking, and as long as it's continuously exposed to that initial source vibration, the amplitude of the shaking will keep increasing. With the wine glass, zoom tight, the amplitude increases until the glass physically can't flex that far and it just breaks. And eventually the same thing happens with bridges. Thankfully, despite this particular guy is getting a dog out of a car. Both of them survive. The bridge doesn't. No humans died because everyone got off the bridge when it started becoming rubber. However, as long as you keep applying the source of vibration, the amplitude will just keep increasing. And
Total collapse.
good night.
So how are they supposed to take that into account?
It's very, very hard to. That said, suspension bridges are probably the most egregious because they have the most flexibility. Ideally, you just want to make it as inflexible as possible. Oh, no, that's not entirely true because you want to make it earthquake proof and thermal expansion proof. Engineers, architects have a very hard job. There's several reasons. I'm specifically not a civil engineer. It takes a lot of rechecking every single possible bolt to keep stuff like this from happening, while also taking into account thermal expansion, what's the risk of earthquakes in your area. There's 10 million things to keep track of. Okay. We have kind of just been jumping all over the place between the greatest hits of waves. Next time we will start talking about the specific things that the physics names for the phenomena that you need to be familiar with. At least to end on, though, I want to mention briefly something I've kind of glanced over, and that is the electromagnetic spectrum. It's pretty easy to classify all sound waves as the same thing. If you can hear it, it's sound. You change the frequency, you change what type of sound you're hearing, what pitch. With visible light, you change the frequency and you change what color you're seeing. But if you change the frequency past the frequencies that the human eye is capable of seeing, you get different types of electromagnetic radiation. Light is just one member of this whole family of electromagnetic wave types. There's lots of different types of electromagnetic radiation that is essentially the same thing. It's all one electric field wave and a magnetic field wave oscillating together as it travels forwards. All of these types of waves are that thing. The only difference is what frequency they are, and therefore their properties when they hit things. The list from lowest frequency to highest frequency is radio waves, infrared, visible light, ultraviolet, X-rays, and gamma rays. All of them are the same kind of thing. The only difference is their frequency and subsequently their wavelength. And you may have noticed, going from right to left, you increase in danger. Radio waves, harmless. We're blasted with radio waves all the time. You're carrying radio wave producing and detecting devices with you all the time. All of our communication technology uses radio waves. We use radio waves because they're harmless to humans. They pass through us and do nothing. They might not even pass through us if they can be stopped by a cinder block wall. We just absorb them and nothing happens. They're harmless, which is why all of our communications technology is based on them. You increase the frequency from radio, there's actually a band missing here. There should be a stripe that says microwaves, like the kind the food warming box uses. Those are dangerous though, because when those hit water and metal, they start eating up. We reached the end of the period. I won't keep you too much by talking about every single member of this family, but note that all of these, including microwaves, there's a missing band there, I apologize.
Is IR infrared?
IR is infrared, yes. I'm always very particular about that pronunciation. Yes. Infrared is just red light that is too low frequency for the human eye to track, and ultraviolet light is just violet light that's too high frequency for our eye to track, unless you're a bee or mantis shrimp. So next time we will continue differentiating between the members of this EM family and start talking about the main thing that we need to make sure we conclude before the end of light, sound, and waves, and that is wave boundary interactions. Any questions? Okay. You please have a wonderful day. There will be a very short homework assignment posted. It'll be due by this Friday. Again, short. We have about half the time to work on it. Do come to lab and be aware of the 30-minute assessment that Tuesday and Thursday lab will do this week, and Wednesday and Thursday lab will do this week, and Tuesday lab will do next week. Thank you all. Have a nice day and a nice lunch.